Chapter 2 in Human Growth and Development, we start to look at the biological beginnings of life and prenatal development. I divide this chapter into 2 weeks because I like to do a lot of focus on prenatal development because it is very interesting to students. So let's think about the nuts and bolts, very high level view of the biological beginnings. One of the things that we are seeing is a higher incidence of multiple births. There are several reasons that they hypothesize as the cause of this. The first one is the age of mom. What we know about the biological clock, if you will, of the woman is that as she gets closer to the end of her reproductive window, she often will have multiple ovulations per weekly or per monthly cycle. So because of that, you might have a higher incidence of fraternal twins because a fraternal twin is 2 egg and 2 sperm. So if she's ovulating multiple times, you have more incidence of the fraternal twins. You also might have the fragility of the egg that actually can get fertilized and then split, and then you have potentially higher incidence of identical twins as well. So mother's age is one thing, but another thing is that's actually often related to mother's age too, is they find that sometimes women in their later cycles are having difficulty getting pregnant and they're getting a little bit concerned with maybe they're at the end of their time where they can be a mother. So they might seek fertility assistance. And fertility assistance most often involves drugs that can stimulate ovulation. So you have multiple ovulations there, or a procedure that has a lower success rate. So often they will implant multiple fertilized embryos so that they have a better chance of success. So both of these are kind of involved in why we're seeing more multiple births. Another thing that is interesting, talk to my sister who has 3 boys, is the sex of the child. So the 2 chromosomes that are sex chromosomes are the 23rd pair. And on this pair, if you're a female, you're going to have 2 X's. If you're a male, you're going to have an XY. And every single egg cell is XX. Sperm cells, on the other hand, can be XY or XX. So, or I'm sorry, every single egg cell is an X. Sperm cells can be X or Y. So when they combine and is fertilized, you can potentially have an XX or an XY. So if it's a X sperm cell, then when it fertilizes the egg, you're going to have an XX or a little girl. And same is true with the X and then the Y sperm cell, you're going to have an XY or a little boy. So in this case, you can see that the father who produces X and Y sperm cells is going to be the one who determines the sex of the baby. So here is what I was talking about, very high overview of genetic principles. This is definitely not a biology course. This textbook covers it in very low level. There's not much information. And honestly, what I need you to know is just the very basics. So we're taking kind of back to when you learned probably in elementary school or middle school, the principles here, the dominant recessive principle, which basically says that the dominant gene is going to exert its effect over the recessive gene. So that would look like in a the square, a Punnett square, it's going to be the big B and the little b. So for example, if we're looking at hair color or eye color, the dominant gene for eye color is brown eyes, so that would be the capital B, and the recessive gene is blue eyes, so that would be the little b, or 2 of them, I should say. So if you have a combination that is 2 small letters, 2 B's like that, you see on the second one, you're going to have a recessive gene that is expressed. So if you're looking at a family and you say dad's got dark eyes, mom's got blue eyes, dad is either big B, little b, or two big B's, and mom is going to be two little b's. So when you do the square and you look at what the possibilities are, you're going to potentially have probably, I think it ends up being 75% chance that it's a dominant gene, brown eyes, and 25% chance that it is a recessive gene or blue eyes, just depending on what dad's actual genotype is. Another thing is the polygenic inheritance. This is a characteristic that is influenced by multiple genes. So there's a lot of different genes that are going to influence what this particular characteristic looks like. And if you remember, like I do from when I was in middle school, I remember our teacher saying genotype is your genetic blueprint. How you remember that from phenotype is PH, like photograph, it's what you see, it's the observed characteristics. So that has stuck with me for many years, and I'm passing it on to you in case your science teacher did not tell you that. So your genotype is your genetic blueprint. It's what's on the chromosomes. And you got your phenotype, which is what you can see. It's easier to change your phenotype with a little hair dye, that sort of thing. But your genotype, for the most part, cannot be changed. So when we look at nature versus nurture, we're looking basically at behavior genetics. We want to know what is the interaction between heredity, genes, and the environment. So from that, we have these different elements, the nature versus nurture, which is that controversy I mentioned last week. That is the most influential controversy in lifespan development. You also have twin studies, and these are studies that are done when you look at twins that were separated and you look at them in terms of, are they more like the person that they were raised with, which would support the influence of nurture, or are they closer to the people that produced them, which would give the evidence for genes or heredity nature. Adoption studies are similar. They would look at a child that's been adopted and they look at where they were raised and look at how the similarities are between them and the people that raised them or the people that produce them. And then the reaction range is something that's kind of like a bell curve, if you will, a little bit. It's basically what a person's given abilities are based strictly on nature, and then what the impact of the environment is, either to the positive or the negative of that, based on what they're raised. So for example, if you had a child that had the capacity when they're born to have an average IQ, which is 100 points, but they were raised in a very cognitively enriching environment, and they were pushed and they were read to, and they had a lot of positive parenting, and there was a lot of reinforcement and emphasis put on education, you might find that those children are going to be more likely towards the higher side of normal. Whereas if they were raised in a chaotic, stressful, neglectful environment, you're going to see a totally different IQ score. So now we're going to talk about a couple different biological or genetic abnormalities. Some of them are caused by environment. Some of them are caused by just unfortunate luck. So a set of chromosomes divides improperly or something like that. So Down syndrome is the most common genetic abnormality. It's caused by a third chromosome on the 21st pair. So they often call it trisomy 21. It can be caused by environmental toxins, but it is also very linked to maternal age. They find that young moms and much older moms are higher risk of having babies with Down syndrome. If you look at the statistics after you hit 35, which they consider advanced maternal age, there is a sweeping increase in cases of Down syndrome. Some characteristics of babies that are born with Down syndrome include distinctive facial features and a mild retardation. Some other ones include the sex chromosome abnormalities. These are when the sex chromosomes do not divide properly or they divide incorrectly. The Klinefelter's syndrome, this is evidence in males. What happens is they have underdeveloped testes, they have scarcity of sperm, they may not be able to produce children. Usually there's not intellectual deficits, but sometimes there are language or learning disabilities. This happens about 1 in every 800 live births. Another one is hemophilia, and this is a condition that babies are born where they have clotting issues. Their blood is lacking the properties necessary to clot. Another one is Fragile X, and in this one, there is an abnormality in the X chromosome. Most often, it results in some sort of mental delay or deficiency. And this one is obviously going to be more common in boys because girls have 2 X chromosomes, so there's a backup, where boys have only the single X chromosome. Some gene-linked disorders are PKU. This is a condition where babies are born unable to metabolize a substance that is needed to produce proteins. Phenylalanine is what that substance is. If this is a nature versus nurture thing, because that is genetically nature, this is what they're born with. However, nurture impacts whether the mental retardation develops or not, and if the baby or the child is given foods that they're not allowed to eat over and over again, because what's going to happen is that's going to build up in their system and then result in the mental retardation. If you've ever looked at a product that has artificial sugar in, for the most part, they all say, caution, phenylketonuria, do not eat this. It contains phenylalanine. Another one is the sickle cell anemia. And what happens in this is there's a deformation of the red blood cells. So again, taking myself back to elementary science, we had to draw the red blood cells, and the teacher described them as, red fluffy donuts. So they're pliable and they flow easily through the veins, whereas the sickle cells do not. They are hardened, they are shaped like a sickle, and it's painful. And this is more more often this happens in African Americans, about 1 in every 400. And spina bifida, this is one of those, I say again, kind of nature versus nurture type of things. There's a strong relationship to the taking of prenatal vitamins. If women are pregnant and take prenatal vitamins, they can reduce about 40% of the cases of spina bifida. This is a neural tube defect. It can either be a damaged spot in the neural tube, or a hole in the neural tube, or sometimes even a tumor that grows out. You can see pictures of it. It's sad because, like I said, about 40% of those can be prevented just by taking those prenatal vitamins. Okay, so how do you know if your child has a abnormality? Some that you can test for, and some, unfortunately, you find out when the baby's born. Ultrasound technology is huge. It is not just, let's see if we're having a boy or a girl, let's see what we can see. It's very much a diagnostic tool. And your main ultrasound that a woman has when she's pregnant is right around 20 weeks. It takes probably an hour to do because there's all of the measurements that are being done. Yes, at that time, you can also find out if you're having a boy or girl, if you should want to do that. But the big thing is it's for diagnostics. And what happens is the high frequency sound waves bounce off the solid tissue in the bones, and the echo that it produces is what you see in the visual representation. So if you think about it, when you're looking at the screen and you see the black screen and the white, that's why it's basically a visual representation from sound waves. So that's why it doesn't have the perfect view. Now the 3D and the 4D, those have so much better technology. Another one that is very not invasive to mom or baby is doing pre-pregnancy genetic testing. When a woman is pregnant and is going in for her first appointment, she will do a big paper report that says all of these different questions about her health and mental history. And this is part of that you can do if you see on that list that there might be some genetic indication that she could be a carrier, or maybe Tay-Sachs or sickle cell run in her family. It's something that they can do blood tests for. And then when you look at the next two that are a little bit more invasive, you've got the alpha-fetoprotein test, and this is a blood draw from mom. And if they see high levels of alpha-fetoprotein, that means there might be potential issues with the neural tube, so indicating spina bifida. And these tests can be done in the second trimester. Two other diagnostic tools that I've got a visual for are amniocentesis and chorionic villus sampling. Amnio is when they draw a small sample of the amniotic fluid. This is done about 15 to 20 weeks gestation. Because of that time frame, it is more accurate than the CVS. The CVS is done earlier, between 8 and 11 weeks. And what it does is it draws tissue from the chorionic villi. This will eventually become the placenta, but right now it's tissue at this point. The risk with this one is because it's done so early, like in what they call the most fragile part of pregnancy, anytime before 13 weeks, you have a higher rate of miscarriage, 1 in 100 to 102 or to 1 in 200 chances by having this procedure done. So it's one of those things you definitely want to consider. So here's the two visuals. And as you can see, ultrasound is used in both of them to guide what is happening. The ultrasound and a syringe takes cells from the amniotic fluid here, and then that fluid is tested to look for the potential or issue. And then here on this one, you've got the ultrasound that is guiding the intervaginal catheter that is taking cells from here, this chorionic villi. And that is the last of the basics of biological beginnings. This is going to begin our week 3 conversation on prenatal development. So I'm going to go ahead and stop right here. And the next one in chapter 2 will be conception and prenatal development.